Hello, everyone, and greetings to all the Furality attendees. We're excited to have you all here today. Welcome to our panel, Udon Shop, from Simple to Synced. Today, we're going to show you what Udon Shop is, how it works in VRChat, how to get started with it, and how small beginner ideas can grow into larger multiplayer systems. We hope this helps make Udon feel a bit more approachable, whether you're completely new to it or already started to experiment with it. Ooh. Come on. Here we go. So before we begin, a quick introduction. I'm ImmortalTheOwl. I've been creating content for VRChat since 2022. I've got over 6 years of scripting experience from Arma 3, over 5 years as a 3D artist, and I've also spent time working with Unity shaders and world creation. Joining me today is Superfriend, who's been creating content for VRChat since 2018.
Yeah, so like you said, I'm Superfriend. I've been making content since 2018. I spent the last 4 years creating games and worlds with Udon. Some of my work includes Solar System Sandbox. One of the more popular works is Hide and Shriek. And a big project I've been working on for the last couple of years that I'm really excited to announce soon is Gone Witchin'. So keep an eye out for that. Besides that, I've been spending the last 7 years as a professional software engineer, specializing in robotics. During my career, I've made just about any kind of robot you can imagine. So if that's something that interests you, come talk to me.
Very nice. So here's the general shape of what we'll be covering. We'll start with what Udon is and how Udon Shop fits into that. Then we'll go over a simple pattern that shows up in a lot of beginner scripting. After that, we'll walk through some basic examples. And then I'll hand things over into the advanced multiplayer and synchronization side. The goal is to take you from the basics into more advanced systems while keeping the path between those steps clear.
Yeah, and one thing to note, this is going to be a fairly code-heavy presentation, but it's meant to be used as a reference. So if you don't pick it up all in the first try, don't worry too much. Come back to it, and whenever you're trying to implement certain functions or certain functionalities, and yeah, give it a look then. Also, everything will be available on GitHub. You can follow this QR code or go to the URL. It'll be there as long as GitHub's around, which I expect will be a while. So yeah, feel free to download it all. There's also some extra stuff in there that we won't be covering during the presentation just for the sake of time.
Yeah. So what exactly is Udon? At its core, Udon is VRChat's scripting system. It's what allows world creators to make their worlds interactive instead of just static spaces. If you ever interacted with buttons, doors, or played about just about any VRChat game world out there, I can almost guarantee that Udon was involved behind the scenes in some way. So really, Udon is what powers interactions in VRChat worlds. When people first start with Udon, one of the first things they notice is that there are two main ways to work with it. The first one being Udon Graphs, which is the visual node-based workflow. The second one being Udon Shop, which is the code-based workflow that looks similar to C#. Both are part of the same underlying Udon system. They are just two different ways of building logic. Udon Graph can be a nice starting point if you prefer visual logic, while Udon Shop is often more comfortable if you prefer reading and writing code directly. So it is not really one replacing the other, it's more that they are the two workflows for the same system. So how does Udon Shop actually work? With Udon Shop, you write code in a C#-like style inside Unity. That code is then compiled into Udon bytecode, which is what VRChat actually runs. So even though it looks similar to normal C#, it is still running under VRChat's Udon environment. That means it feels similar, but it also means it does not behave exactly the same as regular Unity C# in every situation. Still, for a lot of people, Udon Sharp is a very approachable way to start building interactions because it lets you express logic in a clean and readable way. There we go. Before we get into the examples, I want to point out one pattern that shows up again and again in beginner scripting. That pattern is states, then events, and then visual update. First, something keeps track of the current state, and then an event happens, like a click or a trigger, then something visible changes. That is a really useful way to think about beginner Udon scripts, and you'll see that same idea in the examples we're about to show you. Before we jump into the examples, I just want to quickly mention the tools that we recommend for getting started. For this panel, both me and Superfriend are using Visual Studio Code. It's lightweight, fast, free to use, and works very well for this kind of scripting workflow. For extensions, we recommend things like C#, C# Dev Kit, and the Unity extension to get started. And then you got the optional extras depending on how you like to work. That does not mean that Visual Code is the only editor you can use, but is the one we recommend as a solid starting point.
So what about AI tools? Well, things like GitHub Copilot, Claude, ChatGPT, and Cursor have become really powerful in recent years and can be a really useful tool in your toolkit. However, if your goal is to learn, I would recommend against using them, or at least using them only like a search engine. And because the reason is, a lot of learning is trial and error. So when you use these tools, they'll kind of just give you an answer or a solution to whatever problem you're trying to solve. And it robs you of that opportunity to really learn. Now, you can learn from their example, but in my experience, real learning comes from experience. One more thing to note is, while these tools do know Unity and they do know C#, they don't really know Udon. So they'll oftentimes suggest things that aren't possible with Udon. So you have to be really careful not to run into rabbit holes where you're implementing a bunch of stuff that doesn't actually work. So just keep that in mind if you do end up using these tools. And one more thing, if you would otherwise not make something, if it weren't for an AI tool, use it. Like, go for it. Like, it's honestly, they can be really empowering. So, if you would otherwise not, if you don't want to learn, you just want to make something, go for it. There's nothing stopping you.
Alright, so now that we've covered the foundations, it's time to show off some basic examples. In the next few slides, we're going to walk through a few basic interactions and then look at the code behind them. The idea is to not overwhelm you with code. It is to show how these small examples follow the same pattern, or simple pattern that we talked about earlier. So the first one being a simple button. I believe we have a video for that. So when clicked, it swaps color. It is small, immediate, and a very good first example because the player gets instant feedback. But what about the code behind it? So for this button, the main thing to notice are the values at the top, the isOn variable and the interaction logic. At the top, we assign the button renderer and the two colors we want to switch between. And then we have the isOn, which is just keeping track of whether the button is currently on and off. In start, we make sure the button begins with the correct color. And then in interact, we flip that state and call update color, which applies the correct material color. So even in this small example, we can already see the pattern of storing states, reacting to inputs, and then updating the visual results. It's also worth noting that this button is local only. So when a player presses it, it changes it only happens on their side. For a beginner example, that's actually quite useful because it keeps the script simple and lets us focus on the basic logic first. And then next up, we have a teleport pad, which we also got a video for. Instead of clicking an object, this one reacts to when the player walks into a trigger. So it starts introducing world-based interactions, much like so. Cool. What about the code behind that? Well, the most important part are the values at the top, the trigger checks, and the offset calculations. At the top, we define which pads we want to send the player to, and then how long the cooldown lasts, and when the next teleport is allowed. Then in on-player trigger enter, the script first checks that this is the local player, that a target pad exists, and then that the pad is not on cooldown. After that, the script works out where the player was standing on the original pad and maps that same position onto the destination pad. That is what makes the teleport feel more natural instead of always dropping the player into the exact center. So that covers some basic examples. The main thing I want you to take from those is that even simple interactions already teach a lot about the logic you end up reusing later on. From here, we're going to start moving into more advanced side of Udon Shop, especially multiplayer synchronization and shared systems. So I'm going to hand things over to Superfriend over here for that next part, because he can explain it a hell of a lot better than I can. On to you.
Yeah, so we'll be covering some advanced examples. What we'll be covering are sync variables, ownership, synchronization modes, network events, persistence, including player data and player objects, and as a bonus at the end, fizzbones and contacts. So, jumping right into it, starting with sync variables. In Udon Sharp, you can synchronize a variable over the network simply by tagging it with Udon synced in your code. Simple as that. See you next year. But in honesty, most basic types are supported, such as booleans, integers, strings, floats, vectors, and quaternions and colors. So there's a couple more, but you get the point. Udon also optionally allows for interpolation and smoothing for synced variables. What this means is you can tag a Udon synced variable with the interpolation mode, which will let them slowly change over time, or not so slowly, but quickly change over time rather than jumping to a new value. This allows for smooth transitions for synchronized values. One more thing to note, with the basic types, you can't Udon sync a custom class or like an enumeration. You have to stick with the basic types. So, next up is ownership. In VRChat with Udon, synchronization or network synchronization happens exclusively peer-to-peer. So what that means is someone has to be responsible for the values of every object in the world. So how do we do that? With owners. So owners tell Udon or VRChat who is responsible for the state of a certain object. So by default, the master of the world, whoever loads in first, is the owner of every object in the world. But you can transfer ownership through a handful of methods. So first off is with the VRC object sync component. It has an option for ownership transfer on contact, but in general, when you pick up an object with a VRC object sync on it, you automatically become the owner of that object. The reasoning for that is it synchronizes the movement of that object. So if you're not the owner of it, it'll be a little jump in your hand. So That's the first method. Second is programmatically. You can set the owner of any object with the networking.setOwner function. And we'll show you how to use this in a moment. And you can also check the ownership of a certain object. So who is the owner of this with the networking.getOwner and networking.isOwner commands. So there are 3 types of synchronization modes in Udon. First is none, which we won't really cover because it's none. There's no synchronization. And the main 2 are manual and continuous. So starting with continuous synchronization occurs every 10th of a second, so 10 hertz. And it's limited to 200 bytes of data per serialization for a particular object. On the other hand, manual synchronization occurs only when programmatically triggered, such as we'll show in a moment, and is limited to 280 kilobytes per serialization. You'll note that's over 1,000 times more data per serialization than continuous. Now, there is a limit to the amount of network traffic that you can put through in a single second. That's 11 kilobytes per second. You'll notice that's a lot lower than 280 kilobytes. So if you synchronize that much data, you're going to clog the network really fast. So you have to be careful not to clog the network. Otherwise, your performance will suffer and things will slowly, they won't desynchronize necessarily, but you'll see degraded performance. So because of that limit, you want to generally prefer manual synchronization. The reason for that is while continuous synchronization can be used sparingly, you have to keep in mind that anytime you add a new synchronized variable, or a new Udon sync variable, if you're using continuous synchronization, it's going to be using the network constantly with no breaks. Every 10th of a second, it's going to update. So with manual synchronization, you only update when you need to. So let's see how to implement that with a sync button. So same button as before, but synchronized over the network. You'll notice it also has the addition of a small counter above it, which tells you how many times the button has been pressed. So you'll see Immortal clicking the button, and it's updating for me. And then I go up and press the button. It also updates. So, how do we implement this? Well, for starters, we want to use that little text asset to count up our clicks. So we need to import the tmpro namespace using the tmpro using directive on the very top. Next, you'll see this long string that says Udon behavior sync mode, parentheses, behavior sync mode.manual. This is telling Udon that we want this script to be running in manual mode. Now, there's a drop-down menu for all Udon sync scripts, or all Udon scripts, in the inspector that lets you select your synchronization mode. If you're implementing manual synchronization in a script, you never want it to be on anything except for manual. So if you set it here, that drop-down menu grays out and you're locked into manual mode. So we use that decorator, and then we have our text component and a couple of our other things you might recognize from the first example, our colors, and then the isOn value, as well as a new one for the number of button presses. You'll see a new thing next to those 2 values, which says Udon synced. That's the Udon synced decorator, and that tells the system that we want to sync those variables over the network. Next up, you'll see our start function, where we set everything up in the beginning with our apply color and update text functions. Let's take a look at those. First up is update text. In here, you'll see a kind of spooky looking little thing with a $sign and some quotes. This is an interpolated string. Basically, we're saying we want to set the text of our little counter to say presses, colon, space, and then the number of button presses that you see in the curly braces. So this will say something like presses 11, and we'll end up with the result that you saw in the video. Next up in our apply color function, we have another kind of spooky looking thing, but it'll come up a couple times, so we're going to cover it here now. what you see is a conditional statement. This is saying that whenever the condition is set, that we're going to set the value on the left to something from the right. So this is a shorthand that's equivalent to an if-else statement. So the equivalent statement here is, if it's on, set the material color to color A, otherwise set it to color B. So looking back at our conditional statement, we see is on, question mark, that's our condition. Then color A, that's the value we set to it if it's true, colon, color B, which is the value we set if it's false. So reading through that again, if it's on, color A, otherwise color B. Next up, we have our interaction logic and our serialization. So serialization is the methodology by which we pack data and send it over the network. So when you hear that word, just think sending data over the network. So first, we have our interact function. This is a virtual function, so we need to use the override keyword. And this basically makes our object interactable. So when you click on it, it does something. Next up, you see networking.setOwner. Before we change any of our variables, our synced variables, we need to make sure that we're the owner of the object. So what do? We set the owner by networking.setOwner, and then we have networking.localPlayer. That's the local player to this script who has triggered the interact function, and then GameObject, which is the game object associated with the script. So we set our owner, and then we change our variables. Is on and button presses increments. So we flip is on and increment our values so that it goes up by 1, and then we apply our color and update our text. Lastly, we have the request serialization command. This is what tells Udon that we want to synchronize these values over the network. So request serialization basically means send these values over the network right now. So we do that. Then on the other player's clients, you have the on-deserialization command or event. So this event triggers whenever a sorry, I got distracted. This event triggers whenever a serialization command comes over the network on other people's clients. So they receive the data and then they run this function. So when they receive that data, we apply the color and update our text. Next up, we have late joiner logic. So when you're doing manual synchronization, you need to be careful about late joiners, and you have to handle that case. Otherwise, it'll sync for everyone who's there, but someone comes in late, everything gets desynced, and you have a bad time. So what do? We simply override the onPlayer join function, and we request serialization. So when a player joins, we serialize our data, send it over the network, everyone gets synced, and everyone's happy. Next up, we have network events. So there's two main types of, or two main methods for synchronizing data over the network, or doing things over the network in Udon. And that is synced variables, which we just covered, and network events. Network events are a method for triggering functions on other players' clients. Now, every network event is made up of two parts: a network target and the name of the function that you want the event to trigger. So there's four main network types, or network target types. All, which is everyone in the instance, including you. Owner, which triggers the event for only the owner of the object. Others, which triggers it for everyone but you. And then self, which triggers it just for you. So big news in recent years, you can now send data with network events. If you saw some previous panels on Udon, you might have seen that you couldn't do that. Well, now you can. You can send up to 8 parameters along with any network event, with the restriction that the types that you can send over the network must be the syncable types: the bools, strings, floats, vectors, quaternions, colors, etc. And one more caveat: methods that take parameters as inputs, or network events that take parameters as inputs, must be marked with a network callable attribute to be called over the network. Otherwise, they just won't go. Now, it's good practice to mark all network methods with network callable. for the sake of compatibility in the future. So let's look at an example of using network events with a synced door. So you'll see Immortal goes up to the door, opens it, walks on through, and then I'm also able to update the door. And he might be a little taller than the door, but it works on both sides. So let's implement this. First, we start with the Udon network calling using directive. This tells Udon that we want to use the network callable attribute. Otherwise, if we don't import this, then we won't be able to use that attribute and we can't use our methods over the network. So we have to do that to do network events. Then we have a bunch of stuff that handles how the door works. Things like the transform of the door, whether or not it's open, a swing speed, some open and closed rotations, a target rotation, an initial rotation, whether it's moving and whether it starts open. So we'll cover most of that stuff in a moment. Starting with our start function, since we want this door to work anywhere and have the flexibility as a world creator to place the door wherever we want, we need to stave its initial rotation. So we get our initial Euler angles from the door transform, and then we check whether or not it starts open. Next up, we have our interact function, where we're going to send our door event. So whenever we click on the door, we send our door event. And then we have our late joiner logic, which does the same thing, checks if the owner of the object is the local player, and if it is, we send our door events. So what does that send door event function do? Well, basically, it checks if it's open, and then sends a network event to close it. And if it's closed, it sends a network event to open it. But you'll see these big blocks of code that say send custom network event. That is how we implement our network events. So it's send custom network event, parentheses, and then this big long string of stuff ending with all. So yes, it's always that big. Yes, you just got to get used to that. It's not my fault. I'm sorry. But basically this says we want to use the network target of all. So we want to send this for everybody. And then we have the name of our function, which is name of closed door. So you could just put in quotes closed door here. But there's a really good reason to use the name of function. When you're working with an IDE, functions can keep track of the references to that function. So when you have a method that is being used somewhere, above the name of that function, it'll say X number of references. If you use the name of function, that reference list will actually send you here. But if you just use quotes, it won't. And you might see something saying 0 references, think to yourself, oh, this function is not used, and just delete it. In which case your world would break. So it's important to use the name of function when using synced custom network events. So next up, we have our open and closed door functions. You'll see at the top the network callable attribute. So we tag them with network callable to say that we're going to send these events over the network. And then we have a couple things inside. First, we have a toggle for if it's open. So the open door says is open is true. And then you have this big conditional statement that is generating the target rotation based on whether or not it starts open. We won't go too much into it, but basically it's saying if it starts open, give it a different rotation than if it starts closed. Then we turn our target Euler angles into a quaternion, which we don't have enough time to cover in depth, but effectively quaternions are the main method by which you want to use for rotating things in space in Unity. Euler angles are a vector 3 representation and have problems with rotating in something called gimbal lock. So we want to use quaternions, which are a 4-dimensional description of rotation. And that can be spooky, but don't think about it too much. Just use them. You don't have to know everything about quaternions to use quaternions. So suffice to say, just quaternion.Euler, transform those angles, and get a rotation. And then we have is moving equals true. So that's saying to our code that we want to start moving. Then we have the closed door function, which is basically the same exact thing, just with different angles. Lastly, we have our fixed update function. So the fixed update function runs 100 times per second, no matter what, unless you're really lagging. But it doesn't matter what your frame rate is. The fixed update function, so if you're running at 30 frames per second, the fixed update function is still going to run at 100 frames per second because it's completely CPU bound and it doesn't pay attention to your visual frame rate. This is used for things like physics, like a rotating door, for example. Since it runs that often, and we're using an update loop, we don't want this to be triggering all the time because there's a lot of code here and that could slow things down. So we use gating logic. That is moving variable. We use an if statement to say, if it's moving, then run this code. Otherwise, skip it. So next up, we have our door transform.local rotation equals quaternion.rotate towards blah, 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 blah. We'll cover that in a moment, but rotate towards is the main method you want to use when rotating things in space. So when you want something to rotate, don't worry too much about doing weird math, just use quaternion.rotate towards. There's a couple other options you can find in the documentation, but this is kind of the most useful one. So it has a couple inputs. First is our local rotation, which is our current rotation. Then we have the target rotation, which is where we want to go. And then we have a amount of rotation for this particular frame. So we calculate that amount by multiplying our swing speed by time. Speed times time is position. So in this case, we have or distance rather than position. So we have an angle here, and we use fixed delta time since we're using the fixed update function. And fixed delta time is the time that's elapsed between the current update of fixed update and the last one. So lastly, we check whether our rotation has reached its target. So quaternion.angle measures the angle between two rotations. We use our current rotation and the target, and if it's less than 0.1 degrees, then we snap it to the target rotation and tell everything to stop moving. One more example. Pardon me while I take a drink real quick.
Remember to stay hydrated, especially at times like this.
Hydrate or dihydrate. All right. So another example of using network events is color randomization. So in this case, we have an object pool which we're using to spawn these balls. And you'll see that they spawn with a random color. So whenever they pop up, they have a random color, and you can throw them away as you please. We'll cover object pooling the object pooling is not going to be covered in this presentation, but it is in the GitHub if you want to see how that's implemented. So how do we do our color randomization? Well, we have a couple things. We have our renderer, our material, and our color. And then we have the onEnable function. This function basically says whenever this function is enabled or turned on, then we want to do something. So whenever this turns on, we want to randomize the color. So we check if we're the owner of the object, then we randomize the color. Taking a step over to the right, let's look at how we do that. Well, first we generate a random color with the new color command, and then we send our custom network event to set the color. You'll notice we have send custom network event, our network target of all, and the name of set color, and then one more thing, which is our random color. So this is the case of using a network event with a input parameter. So you're sending this data over the network and calling that function on other people's clients. So taking a look at the set color function, you'll see we have our set color, and then it takes an input of color, of type color called new color. And you'll also always remember the network callable attribute for network events. So in here, we set our our material color to the new color, and then we save that color in our current color variable. The reason we save it is for late joiners. So looking to the left, bottom left, we see on player joined. If we're the owner of the object, then we send our custom network event to others, so to everyone else, with our set color function and the current color. So let's hop into persistence. So persistence is awesome. You can do a lot with it, but basically it allows you to save data between sessions and worlds. This is useful for things like preferences, settings, unlocks, items, progress, and more. You can do so much with persistence, and it really makes your worlds feel good. It feels great to load in somewhere and have your data there from last time. So it's usually used for per player save data, and you always want to be careful when using persistence to only save what you need to. There is a limit to how much data you can save, and if you hit that limit, bad things start happening. The limit's pretty high, so you have a lot of flexibility, but it is something to keep in mind. Now, there's two main methods for handling persistent data. There's player data and player objects. We'll be covering both of those. Starting with player data. So I don't have a better way to say it myself, so I'm just going to quote the Udon docs. Player data is a key value database for storing persistent data about players, such as their score in a game or their preferences in a world. Simple as, right? But maybe not. So let's go through it. Player data is globally accessible. That means any script in your game or your world can access player data regardless of their network sync mode. That means a script that has no networking can still access, read and write player data. So Udon scripts, and this is really important to note, when you're working with player data or any persistent data, you should always wait for the on-player restored event to trigger before doing anything with the player's data. The on-player restored function or event will trigger whenever their data finishes loading. So if you're going to do something with persistence, wait for that event and then start working with it. Otherwise, you'll have sort of half-loaded data or corrupted stuff, and you can really mess things up. So just always keep that in mind when working with it. Now, when setting persistent data, it can only be set by a local player's client. And how you do that is with the player data.set type. So in this case, set int. And we have our key and our value. So the key is a string, and the value is what, in this case, an integer of the data we want to save. So while you can only set data with the local player's client, anyone can get anyone's player data. And the way we do that is with the get type functions. And first is value equals get string, and then we have who we want to get the value from. So in this case, a local player, and then the name of that value or the name of the key. You can also use the try get x functions, which return a Boolean of whether or not the player actually has that data to load. So if it's their first time entering the instance, try get float in this case will return false, saying that this player doesn't have any persistent data to load, which can be very useful, and we'll show that in a moment. So one example of using persistence that I've been playing with personally for a very large world is persistent player position. So let's take a look at that. You'll see Immortal leave the instance.
All right, see you.
And this is not at spawn. We're just somewhere out in the world, and then he rejoins, and he's in the same spot. So how do we do that? Well, for starters, we need to use the persistence namespace because we're going to be using persistence code. And then we're going to have a couple things going on. First, we have the on-player restored event, which I talked about a moment ago. It comes along with a player. So when that runs, we want to check if the player is the local player. and then we do a bunch of stuff. So we have a vector for our last position and a quaternion for our last rotation. We're going to use the try get vector3 and try get quaternion functions to try to get those values. So we have our has saved position and have saved rotation bools, which tells our script whether or not they actually have this data to load. And then we try to get it. So we have who are we trying to get it from? So we try get vector3 and then player, that's who we're trying to get it from. Last position, which is our key. And then you see out last position. That's telling it that we want the output of this, if it finds something, to go into the last position variable. So then we check if we do that, the same thing for rotation, and then we check if we have a saved position and we have a saved rotation, then we teleport the player to that place. Lastly, we have a new type of event. It's not new in general, but it's new to this presentation. That is a custom event delayed seconds. There's two types of delayed events: send custom event delayed seconds and send custom event delayed frames. So in this case, we want to send an event delayed by half a second, which is our update interval, and it's going to be our update player position function. So let's take a look in there. Basically, this function checks if the local player is grounded, then save their position. Is grounded is basically saying, is the player standing on the ground? If they're jumping or they're falling, then it won't save their position, so you don't load someone in falling down. So lastly, we have another send custom event delayed seconds. This is basically a custom update loop that runs at half-second intervals. So it's pseudo recursion, i.e. this function calls itself via a custom network event, and it only updates every half a second. The reason for that is persistent data counts against your limit of data that you can send for every second. So they're all contained within that 11 kilobytes per second. So you don't want to always be hammering the network with saved data. Also, this doesn't need to update that often. But one thing to note is when you update player data, it updates all player data. So if you have hundreds of player data items in your key value database, and you're updating it at every half a second, you're gonna bog the network. In our case, this is the only persistence we're using in our world, so it's not so bad. But we're gonna cover in a moment a way to send data more frequently. Oop, can I click the thing? It's not working anymore.
Oh, I have control over it, apparently.
Okay.
Did you already cover player objects?
No, we're here. Player objects.
There we go.
Weird. But, so player objects are a method for sending data faster and contained. But they're also very useful because they are objects that spawn for every player that enters the world. This is wildly useful for all sorts of things. And they're really easy to make. Simply by tagging, or simply by adding a VRC player object component to an object, it becomes a player object. With the option of storing persistent data. So if you add a VRC enable persistence component to a player object, then all the Udon sync variables on that object and its children become persistent, which is really useful. So one thing to note is this also includes the VRC object sync component. So if you have a VRC object sync component on a player object, whenever you load up, it's going to save that position and spawn somewhere wherever it left off last time. This can be a little bit jarring if you don't expect that behavior, so just keep an eye out for that. There are methods for spawning player objects and such, or like retrieving them. So, but we won't be covering that here. So yeah, click. Yeah, I can do it again. Cool.
Yay.
So let's look at an example of a fire wand. So you'll see there's two wands here. One is mine and one's Immortal's, but I can't grab his. So
Mine.
he grabs his wand, and I grab mine.
No.
You'll also notice they're different colors. And then we spray some fire, heat up our block. All is well in the world. All blocks should be heated. So let's implement this. For starters, we have our particle system, our VRC pickup, and our renderer. And then we have an Udon sync variable, which is our gem color. And you'll see that it starts black. So in our start function, the reason I couldn't pick up Immortal's wand is because I have a check in the start function. If I'm not the owner of the game object, then I set the pickupable variable of the pickup or the VRC pickup to false, which says I can't pick that up. So your wand is your wand forever. Next, we have the onPlayer joined, which you'll see the same kind of late joiner logic that we had for our synced button, where we request serialization. And then we have the onDeserialization function, which will trigger and set our material color to the random gem color, which we are going to get in the onPlayer restored function. So first we check if we're the owner of the object. So if the gem color is black, that means we haven't randomized it yet. So whenever we see that color, then we randomize the color with random HSV, and then we set our material to that color and serialize it over the network. Now, this means that that gem color that randomizes the first time you load in will be your gem color forever. Now, of course, you could do stuff and make all sorts of different functionalities. In this case, all we have is this gem color. So next up, we have our particle stuff. So how do we trigger our particles? So we override a couple functions. The onPickupUseDown, which we'll use to start our particles by sending a custom network event with the name of start particles. If you look at the bottom, the start particle function is pretty simple. We just say particles.play. And then we have our onPickupUseDown triggers whenever you click your trigger or click your mouse on desktop while holding an object. Then we do onPickupUseUp, stop particles. onPickupUseUp triggers whenever you release your trigger or release the mouse. Lastly, we have onDrop, which happens whenever you drop the item. And you'll see they stop the particles. And in that case, it's just particles.stop. Bonus time, FizzBones. So, World FizzBones are here, and they're awesome. Woo! They allow players to interact with worlds just like they would with avatars. So, if you're familiar with using them, they work the same way. You set them up with all the same components, and they just work, which is fantastic. But they additionally have some code hooks for accessing their properties programmatically. These are things like angle, squish, and stretch. There's also a couple network events that trigger whenever they're interacted with. That's onFizzBone grabbed, onFizzBone released, onFizzBone posed, and onFizzBone unposed. Next, we have contacts. So much like FizzBones, contacts allow players' avatars to interact with the world. So things like your hand touching an object is possible with contacts without tracking any bone data or doing anything funny. You just put a contact receiver and you smack it. So similar to colliders, they send events whenever a contact sender and a contact receiver collide. And the events that they send are on contact enter and on contact exit. Enter happens when you begin contact and exit happens when the contact ends. So let's look at an example of using that. We have a mushroom drum. You'll see there's a little bouncy drum here, and I can smack it and it makes a noise. And Immortal can pull it up, change its pitch, and smack it himself. You could have a whole chorus of mushroom drums in a world. keep an eye out. I might be doing that soon. But yeah, let's see how to implement that. So first off, we have a couple things. We have our audio source, and we have a fizzbone component. So you'll also note the using directive on the very top that we're wanting to use fizzbone components with the fizzbone.components namespace. So we have a couple variables that are controlling our drum, such as the minimum and maximum speed of contact, the minimum and maximum volume we want to play, some random pitch variation, a cooldown time, so it doesn't have a trigger all the time, and then a last play time. So in here we have on contact enter, which happens whenever when we hit the drum, and in here we have the player that comes along with that contact sender. So we detect what player started the contact, and then we check whether or not they exist. You can have something like a drumstick that doesn't belong to any player, and in that case, you want to ignore the player value. So we get the speed, which is simply the magnitude of the velocity of the contact. We clamp it to our minimum and maximum, and then normalize it so it's a value between 0 and 1. The reason we do that is because we're going to linearly interpolate the volume between our minimum and maximum by that normalized speed. And then we have our pitch, which we're going to use as the stretch of our fizzbone, which starts at 0 plus 1. So pitch is 1 by default. You stretch the fizzbone, it's 1 plus stretch. Then we have our custom network event, which we have our play audio function, along with the pitch and the volume. So
I think it's done. There you
go. Then we have the play audio function, which you'll see is network callable, where we do a couple things. We have our cooldown at the very top. Then we have the pitch, which we'll use that input value of pitch plus some random variation to avoid audio fatigue. Then we enable our audio source and play our clip. Lastly, you'll see an optimization, which is disabling the audio source after it plays. Now, you can only have 32 audio sources in a world active before things start breaking and the audio system goes crazy. It's a Unity thing, and it's kind of unfortunate, but it's there. So if you want to have more than 32 audio sources, you have to enable and disable them whenever you're not using them. So in this case, we send the custom event delayed by the length of the clip plus a little bit of buffer where we disable the audio source. And that's that.
Woo! And that's that. Yeah, that brings us to the end of the main presentation. Well, thank you all so much for coming, and we hope this panel has helped make Udon Sharp feel a bit more approachable. Our main goal was to show you how you can start small, understand the core patterns, and then build those ideas into larger multiplayer systems over time. And then we've still got on the screen, we've still got the QR code and the GitHub link in case you missed it at the start.
Yep. And
all right.
Yeah, hopefully we have some time.
And with that, we'll open things up for questions. Yeah, if there's anything
pretty much
from
at time, but we
yeah,
can probably get a question in for you. Sorry. Let's see.
Go on then.
Happy Robot 33 asks, as someone who doesn't get the opportunity to ever really mess with the param networked events, has there been any oddities or things to look out for in advanced uses that VRChat hasn't documented that you've run into?
That's a good question. I have also not played around with them a ton. I've used them for a couple things, and in my experience so far, they kind of just work, which is excellent news. But the only thing to watch out for, and you'll definitely make this mistake at least once, is if you don't mark your function with network callable, you'll be like, why isn't my function running? Because it will quietly fail. It will not tell you that it's not called. It'll just send the data out into the ether and never call your event. So that's the one big thing to watch out for with param network events.
Great, thank you. And last question, do you have any strategies for minimizing network usage?
Yes. So only sync when you need to. So you can minimize the number of variables, but sometimes you just need a lot of data. So the main method is simply try not to sync all the time. You can do, like, if you have something that's changing rapidly, try to sync it less frequently and use interpolation. That'll hide some of the snapping that you're doing under the hood and let you minimize the amount of network that something is using. I've personally made games that have like thousands of sync variables and they still use only half of the capacity. And that's all from just being disciplined with making sure that when you're synchronizing a value, you actually need to. And it's not never use continuous sync. Basically, never use continuous sync. You can use it if you're making something small. Go for it. It's fine. But like if you're trying to make something really complicated, you'll hit that bandwidth cap really fast with continuous synchronization mode.
All right. Thank you so much. Thank you both. Any final words before we close out?
Good luck, and I hope to see what you guys make.
Yeah,
I'm excited.
Start small, make big things.
Also, we'll be hanging around the Discord. If you have more questions, feel free to shoot them into the Discord, and we'll be around answering them.
All right. Thank you guys so much.
Thank you.
Yeah, thank you for having us. It's been a pleasure.
Furality Ultra! What's up? I'm Mike Callum, and this is going up. Way too long, way too long, way too long. It's been way too long, way too long, way too long, way too long. It's been way too long. How long has it been since I've seen your face? How long has it been since I've heard your voice? All the memories are drowned out by the noise. All I wanna do is to hear your voice. Way too long, way too long, way too long. It's been way too long, way too long. It's been way too long since I've seen your face.